Right, we've got the M1 International A-Level, October 21, question 7. It's an inclined planes question with a pulley, one end light instrumental string attached to a particle A of mass 2m, the other string attached to a particle B, mass 3m, passes over a smooth light pulley, which is up a rough plane, so this plane's rough. Plane's inclined at the angle alpha, horizontal, and tan alpha is 3/4. Particle A is held at rest with the string taut and B hanging freely, and this section goes straight up the plane. So the coefficient of friction is a half, and A is released and begins to move up the plane. And we're going to find the equation of motion. So is the forces, there's the weight acting on B, 3 mg, and the weight acting on A. We've got the tension in the string. And there's a normal reaction, which we're going to need because we've got friction acting down the plane because it's slowing A down. And B is moving down and A is going up the plane. Equation of motion for A. So we'll look at the forces parallel to the plane and use F equals ma. T is in the positive direction because it's pulling up the plane. The friction in the negative direction because it's trying to slow it down. So is the component of the weight. This angle is 90 minus alpha. So the component of the 2 mg is 2 mg cos 90 minus alpha. All that's equal to 2 ma. Mass is a 2m multiplied by the acceleration. And I could write the 2 mg as 2 mg cos 90 minus alpha, 2 mg sine alpha, cos 90 minus alpha, sine alpha, exactly the same thing. And then an equation of motion for B. This is much easier. I'm just looking at the forces going vertically. There's 3 mg acting down in the positive direction because it's moving down, minus the tension because that's slowing it down, is equal to 3 ma. And then we've got to find in terms of G the acceleration of A. Right, I'm going to do a bit of work on this equation of motion for A first. I'm going to get the friction. I'll do some angle work. Tan of alpha is 0.75, which means the sine of alpha is 0.6. You could do the sine of tan to the minus 1 and 0.75, or draw a little triangle. Cos of alpha is 0.8. So if I'm going to do this again, if I look at A, look at the forces perpendicular to the plane, then the R is equal to 2 mg cos alpha, that angle's alpha, because this one was 90 minus alpha. Cos alpha is 0.8, so this is 1.6 mg. So the friction is mu times R. It told us that the mu was a half, so that's a half R, so it's a half of 1.6 mg, which is 0.8 mg. And then we'll look at the whole of the equation of motion again. I've got the T minus the friction, which I've just worked out, minus the 2 mg cos 90 minus alpha, 2 mg sine alpha. Sine alpha is 0.6, so it's 1.2 mg. That's going to be equal to 2 ma. And I can simplify this a bit because that's T minus 2 lots of mg, so equal to 2 ma. And then I solve it simultaneously with the B equation of motion. If I add these two together, it'll cancel out these T's. I've got a T there and a minus T, and I've got a 3 mg minus 2 mg. So that's just mg, and that's equal to 5 ma. Divide both sides by 5 and the m, and I have the acceleration is 1/5 of g. And then we want to find the force exerted by the pulley by the string. Well, the string's like pulling it down because there's a tension there, and it's pulling it down to the left as well because there's a tension there in the string. So I need to find out what this tension is. I can do that just by subbing in the A into this equation. T minus 2 mg is 2m times a fifth g. So if I take the 2 mg over, I'll have mg times 2/5 plus mg times 2, which is 10/5. That's 12/5 of mg. So I know what the tension is now. What I need to find is this resultant force. It's pulling it down and it's pulling it down to the left. So the resultant force looks like this. Now it looks like a parallelogram. We've got parallelogram of forces here. So the T's pulling it down, and this T is doing this as well. So this is the total force. This angle up here is alpha. So if I think about the symmetry of it, the total force is going to be the component of each of these T's in this direction, which is, and each of these angles is 90 minus alpha over 2. That's 90 minus alpha. So each of these is 90 minus alpha over 2. So the whole force is 2 lots of T times cos 90 minus alpha over 2. Now you can get cos of 90 minus alpha, the exact value on your calculator actually. If you did 10 to the minus 1 3/4, leave that in the calculator, do 90 minus the answer and divide it by 2, and do the cos of the answer to that. You won't get 2 over root 5, it'll give you a decimal, but if you square that, it does give you 4 over 5. So you worked out cos squared really, so the cos of alpha is the square root of 4 over 5, which is 2 over root 5. This simplifies to 2 root 5 over 5, and put that into here. 2 times 12 over 5 mg times 2 root 5 over 5, and I get 48 root 5 over 25 mg.